guess it doesn't really matter when I hit record, since you can always cut it out anyway, right?
Yeah, there you go. All right. What's going on, SolidWorks nerds? We're
What's
back
up?
again. How you doing, Garrett?
Good. Took a little bit of a break there. Sorry about that.
All good, all good. I know you've been busy. I've been
Oh
busy
man,
too.
I've done so many certifications. How many have you done in the last month?
Let's see. In the last week, I think I did 6 new ones.
Ah, nice. I think that was the same for me. Yeah.
Awesome, man.
It's
Good job.
always fun learning new stuff, man.
Absolutely. All kinds of fun stuff. SolidWorks certifications. We should probably talk about that at some point too.
Yeah. Yeah. Well, if people are interested, definitely want to do it. So I think people are really going to like what we have to talk about today, though.
Yeah. What do we got for today? Tell us about it.
So today we're going to talk about equations and then just design automation in general, right? There's actually a couple of tools that we can talk about in relation to design automation. There's one that's really good that's been around forever that like nobody uses and they really should. So I'm really excited to talk about that. I think you guys all really like it. But I think first
we get those.
Yeah, go ahead.
We get those kind of questions a lot. How do I make this faster? How do I automate my design a little bit? Really, you alluded to it already. There's one really good answer to that question, but there's a number of different ways you could approach that, right?
Yeah,
so
absolutely. I think the first thing that I want to go over though is our really quick tech tip, right? So I think the first one I want to show you is probably one of my favorite things that it's been around for quite a while inside of SolidWorks. Let me go ahead and show SolidWorks here. So if you have a drawing that you've saved here, let me go ahead and close it. Go ahead and close the other drawing here. I've got this model, and let's say that my coworker goes and they make a change to this. Let's change this to like 42 inches. All right, we save the model, or my coworker saves the model, and then I go and I open up that drawing again. Right, there's a really nice setting that we can change here that will allow us to see the things that actually changed. Right, so over here you can see, you can set the color. So this is like, I think orange. Is that orange, Brandon? I don't know. Mm-hmm. Colorblind, so
you can set. Forget. I have to help you out with that. I always forget.
You can set the color to whatever you want it to be. By default, it is orange. And if you hover over it, it says the name of the dimension and what the value used to be. So this setting is really easy to find. You just go up to the settings here. I say it's easy to find, but when I went to look for it earlier, I didn't find it right away. And I was like, oh yeah, it's over in this other spot. So it's not under drawings, it's under colors. And there's a checkbox down here that says use specified color for change dimension on open. And that color is right in here. Oh, and we could change it. So nice. Really nice option. And if you needed to go back and change the dimension back, you could always go in and do that. And I'm using model items here, so I could change it back to the previous value if I needed to. So
there you go.
But you probably want to talk to your coworker in that case too, so you guys aren't like fighting, going back and forth with these values. I know.
Yeah.
I have done that in the past. So.
Exactly. Yeah, I haven't used that one in a while. That's a good tip. I remember when that came out. That was kind of a fun one to show.
That was one of my favorites to show. Yeah.
Yeah.
Oh, and I'm rocking customer hat today too.
Nice. Hoffman Manufacturing here in Latah, Washington. Shout out to those guys.
Yep.
Right on. Well, let's get into a little design automation practice here. So probably one of the first thoughts that people have when they want to begin design automation is, hey, I'll just use what's already built into SolidWorks, right? We know that we can make parametric features, we can write equations, we can relate things to each other. That's all really easy to do. And I would say that really there's nothing wrong with that. Where it starts to get a little bit daunting or cumbersome is really when you start to use or excuse me, overuse equations. Would you agree?
Yeah, I think it's really easy to do things like creating external references and creating even like circular references when you're dealing with equations.
Mm-hmm.
And that can cause like some serious performance issues, right?
Yeah,
But they do have like,
absolutely.
if you keep them to like a limited scope, they do work really well, right?
Mm-hmm. Yeah, what I think I like equations for is just simple things like, you know, putting in mathematical functions, the kind of stuff that it was pretty much designed to do. If you want to make a feature dependent on something, but maybe a little bit of clearance or something of that nature, that's fine, right? You can do that stuff pretty easily. The situation you mentioned before with like a lot of external references and that kind of thing, that's really starts to bog down your performance the more that stuff you add up.
Yeah.
You know, it's going to take a lot of your time. Can you make a really, really smart model? Yeah. Is it going to take a long time to probably calculate all that stuff that it needs?
Yeah,
for sure. Yeah. So I think one of the things we recommended on the last show was taking a look at some of the tutorials for this stuff. So maybe we'll start there real quick. I'm going to show just a real brief example working through some of that tutorial. So if you guys were to go into your help menu for SolidWorks, click on tutorials, they'll give you this little ejector pin model there.
Ooh, I can't see your screen yet.
I'll give it a second to catch up.
Okay, I see your background anyway. There we go.
Try one more.
We got it.
There we go. Okay. We're rolling. So yeah, like I mentioned, head up to your help menu there. Go into your tutorials. So it'll pull these up here. All tutorials, you'll find one for equations right there. And this one's pretty straightforward. You know, it does a pretty good job of showing you the quick stuff that equations are really good at. So for example, if I've got two bodies that I want to relate to each other, and maybe like diameter of something is dependent on another item, it's pretty easy to set that stuff up. There's a couple ways you could approach this. I'll show you like some on-demand equation building. But the thing that really makes this powerful is it's kind of all consolidated in one place. So if you just go to your tools menu and click equations, it's all right here. So every dimension that's put in your model, everything that you've defined already is really all defined in this list here. So all my sketches, all my features, they're all here.
I really like that. And there's like a couple of different views at the top there that you can choose from. I think that initially kind of confused me. The other thing to keep in mind here too, from a performance standpoint, is that checkbox at the bottom for automatically rebuilding.
Yeah.
That can be that can be a problem, right? If you have a lot of equations. So
exactly. Kind of depends on what you're doing. That's what I was thinking too. Like if you have a lot of equations defined, you may just want to keep that turned off for a little bit, make your changes, and then rebuild on demand when you're ready for it. So yeah, I've got it off right now, but something that you could start with is like if you wanted to define an equation like they have you do in the tutorial that controls the diameter of this shaft, for example, right? You could do something really simple. So to set these equations up, you can just head back to your equations view. Depending on how you want to do this, you can set up global variables or just define equations where a dimension is equal to something. So in the tutorial, they have you do like pin shaft diameter, something like that. To start this out, you can go in and make this equal to a dimension. It's pretty easy to set this up. You just, you know, grab a feature. As soon as you get into this value equation section, you're defining what you want those variables to be. So if I were to just come in here, find my dimension value out in the graphics area, it'll just toss it right in there. So if I want it to be dependent on that, you certainly can. They show you some other examples of like making independent global variables. So if you really wanted to set this up so it's easy to go through and just make some changes from this table, you could do something like, well, I'm going to use that pin shaft diameter that's maybe just some arbitrary value right now. I could toss it in as a number. Then what you'll do is start coming through and defining those equations based on your global variables. So I could say, well, this one's equal to pin shaft diameter. That's the thing I like about this equations editor. You can kind of build this stuff on demand, but it makes sure that you don't put in the wrong syntax anywhere.
Yeah,
right?
it's got some troubleshooting kind of stuff in there too, right?
Yeah, exactly. So that's what I always recommend. Stick to those drop lists. It's going to help you make sure that you pick something that, you know, is actually a usable value that you can take advantage of. Forget exactly what else they had you put in here, but that's kind of one example you could take it with. Another thing you could do here too, like real simple, if I need a little bit of clearance for the hole that this shaft is going to mate into or whatever it might be, I can write another equation for that. Pan this out of the way here. So if I'm just going to say this dimension is equal to global variable pin shaft diameter plus 5 thousandths, whatever the case is.
Nice.
Maybe I'll do a couple other ones here too. Not necessarily based on a global variable. You guys know how to set that up now, but like I can make this.
And you can put comments in over there too, right? So you could specify.
Yeah, that's a really good point. So if I'm going to use this design between the two of us, and you know, I was the one that set it up and you're not really sure what controls what, those comments can be important, because D1 at sketch 2 really doesn't mean a whole lot to anybody unless they are familiar with the design or they go and look for that stuff, right?
Yeah. Yeah, and having done a lot of troubleshooting, I think, with customers in the past, like coming in and trying to figure out what's going on with equations that somebody else has written, it's like trying to decipher somebody's code, right? It can be pretty tricky, especially if you don't put any type of a comment in there like you do when you're writing code.
Yep. So, I mean, you can choose from all kinds of stuff here. Mathematical functions, where if you want it to figure out, you know, sine of a value, cosine, whatever, put in some of that stuff. There's even like if functions. So in the tutorial, they have you go through, and if you were to change the pin shaft diameter, let me just do something like that, get that going. If you were to want to suppress a feature, so for example, like this chamfer, if it's only applicable after a certain value of the pin shaft diameter or whatever, you can grab that feature and actually write a function here to suppress it and unsuppress it based on an if statement. So if I were to say that my pin shaft diameter is less than a certain value, so they go with like 1 millimeter, you just continue writing that statement. It's going to give you the ability to make the correct syntax here. So if you hit your global variables section, you've got those suppress and unsuppress functions. Nice. And so less than 1 millimeter, I want to suppress it, throw in another comma, global variables, unsuppress it. I think I might have forgot a space there, but
it should still be fine.
There we go.
Just hit enter, maybe. It might not like the 1 millimeter. Yeah.
Anyway.
Yeah. But I mean, that's one of the reasons why, like, equations for me, like, it can be tricky, right? Compared to doing like some of the other things, right? One of the things for me with equations is that it relies on the VBA engine. So if the install, if there's something mess up with your Windows install, and you're relying on that equation to run in order to solve your part correctly, you can't necessarily rely on that all the time, potentially. So it is something that can break. So for me, I would rather, if I'm going to rely on VBA, I would just write a macro to do something like that, right?
Yeah, that's another good point to bring up too, is, you know, if you're getting heavy into automation, a lot of times you're better off to have something, a macro, another tool that's doing this stuff for you anyway.
Yeah. And speaking of other tools, for automation, like there really is one tool. It's been around. It's the longest partner for SolidWorks. It's the one that's like, it's in every version of SolidWorks, isn't it?
Yep. Everybody that owns SolidWorks has this tool.
Which to me is crazy, because I only know a handful of customers that have used it, and it's so easy to use. And we're going to show you how easy it is to use here in a minute. I'm going to actually go through the DriveWorks tutorial. DriveWorks is the longest part, I believe, the longest partner. I can't remember if it's them or CamWorks.
I'm trying to remember too. It's one of them. I don't remember offhand.
They've both been around for forever.
Yeah.
But you know, DriveWorks Express is integrated into SolidWorks in every version of SolidWorks, like we said. So it's really like the de facto tool for doing automation. There's a lot of people that do use equations and do use design tables, and I can tell you from doing a lot of support, those have a lot of problems potentially, right? We've seen a lot of those. You kind of cringe sometimes when you see that come in, but it's, I don't know, it's just so much easier to do everything inside of DriveWorks if you can. There are some limitations with the Express version that we have, but it's far more capable, I think, than I thought it was before I went through the tutorial, right? So yeah, Brandon, you just want to show a quick example of how it sort of works?
Yeah. So real quick, if you go to your tools menu, head up to Express products, you'll find DriveWorks Express right there. The thing that confuses a lot of people here is it's going to pop up, if you haven't opened this tool before, it's going to show you a little activation window. It confuses a lot of people because it's like, oh, I don't have a license for it. Well, it's included with your SolidWorks license. You just have to follow the link and get the activation code. So it'll just want you to log into your My SolidWorks account to do that. It's pretty easy. If you get hung up on it, our support team can help you out. But
yeah, it only takes a couple seconds. So
yeah. Once you get it loaded, it'll have a little task pane tab over here. Pretty simple. Now, what I did was just downloaded some of the sample Express projects from the DriveWorks website. If you want to see how any of these work, the tutorial's great, but they have a bunch of other stuff too on their website. So I've got some of those projects available. Like if I make different versions of stairs and ladder systems and stuff like that, I could put those all into my DriveWorks database and just pick what I'm ready to design the next version of today. So if I'm going to, make a new caged ladder for a customer or a 90-degree stair or whatever it is, I can just, pick one of those when I run my project. So whatever I'm interested in, I just hit run. The thing that's really cool about this is you build in all these rules. So it pretty much makes it all foolproof. I mean, if there's certain dimensions that you should or should not be able to use, you define that logic in these forms that you fill out. So, it's
make it
standard options
to break it, right?
Yeah, exactly. So whatever standard options you want on that product, if you're going to have guardrails or not, you can turn these options on and off, all kinds of stuff. Right. And you basically just fill out the form and tell it to go when you're ready. So it's going to go through and basically generate your next model for like a customer specific type of build. That's really what you're getting here.
I think one of the things that's really cool that I wasn't aware of is that it doesn't have to be just parts, right? This could be parts, drawings, and assemblies. Yeah. And I was actually talking to a customer the other day who there were initially, we told them years ago, I think you told them too, right, Brandon, like that they really should be using DriveWorks, right? They asked us when they were switching from one software to SolidWorks, like, how should we do this? And they went with the method using, I think, equations, and then I think they tried like design tables, and they finally gave DriveWorks a try, and like this is making our life so much easier. And
Yeah.
specifically, what I got from them the other day was that there was so many drawing specific automation tools that they weren't aware of. That like there's no way to automate inside of SolidWorks without writing custom code, right? You could do it if you're getting in the API and you're writing your own specialty tools and stuff, but
Sure.
it's all just part of DriveWorks. So
Yeah.
it's pretty cool.
I love it, man. It's there for everybody to dip their hands into. So
All right.
that thing, design automation.
Now it's time for me to show you how easy it is, but I've only done this once before, so just so you know, if I mess it up, it's not probably DriveWorks' fault. This is on me. So to get into the DriveWorks tutorial, we're gonna go the same way that Brandon went to get to their equations tutorial here, just through the help menu. It's in a little bit different spot in 2021 than it was in previous versions, but once you get into your tutorials here, you can just find our DriveWorks Express tutorial. And we're going to go through this example where we have an assembly that also has drawings with it and parts, and just a really cool example of a design that, you know, you're going to get different requirements from the customer, and it's the same but different every time, right? So the first thing that they have us do is create a working directory. So let me just go out. So if I just create a spot, let's create a spot on my D drive here. This is where like all my models are going to live. And then the next thing that they have us do is actually copy some seed files. So we've got all of our drawings, parts, and assemblies here. And this is just from your normal directory. So there's a default directory in the users folder, public, that you can go and you can grab these files.
Nice.
So I'll just paste those in there. All right. And let's see here. Then the next thing that we need to do is actually create the database. So we're going to need to turn on DriveWorks Express like Brandon just showed. So tools, DriveWorks Express, like so. And I'm going to say create database. And I can save my database. I'm just going to go ahead and put it in the same working folder. And I'll just call this gantry. Okay. And then I need to open up the file, the model that this is all going to be based off of. So I'm just going to go ahead and browse and find that gantry assembly file that I pasted in there. Hopefully that was the right folder. Pretty sure it was.
So you're kind of defining, I think you described it as like a seed file, right?
Yeah, everything's going to be based off of this, right?
Yeah. So the assembly is necessary, but the database, what does that do? Is that just stores all the logic pretty much?
Yep, stores all the logic, all the values, file references. You know, databases don't actually store files themselves, but they're really good at like manipulating data. So that's what we're going to be doing inside of there. So let's see, I've got it open. I can see it here. Next thing that we're going to do is probably go over and looking at actually capturing model information. So we could go down to, see our captured assembly structure here, and it'll show all of the components that are inside of the tree, and I can pick and choose different components that I would want to drive, right? And that's all I need to do to include those in there. The next thing that I want to do is start selecting like different dimensions that I want to drive. So basically, I'm going to be capturing different things that I'm going to want to change, right? And equations can also play into this. You could have equations in these lower level models if you wanted to, but it's going to be a lot more powerful to keep a lot of that stuff out and just do it inside of DriveWorks. But we should be able to just double click on this component. That was something I didn't know until I did this just a little bit ago. that's how you actually get into these lower level components and still keep them referenced together. I just double click on it, and then I can go down and say that I want to capture some dimensions here. So there's a dimensions and features. I can come in and double click so I can actually see my, oh, they're doing it with this dimension here to a plane. Running out of real estate here. I can go ahead and click on that guy, and that'll be my dimension, and I can just give this a logical name, right? So they wanted to call this one, what did we want to call it here? Is
that the beam length?
I think so.
Yeah.
Like that. Could add that. And there was another one that they wanted me to get from here, beam height, right? So on the extrude feature, should be able to just grab this guy and call that, oh, beam, beam height, right?
I like beam height better.
Beam height. All right. And then we should be able to go to the leg next. So I just double click on the leg from the captured models tab. And that's how you like navigate inside of here. I think that was probably the missing component for me, and like how do I deal with like assemblies inside of DriveWorks Express, was you just double click on that stuff, which is really cool.
Nice.
And I don't know how much you've used this, Brandon, but for me, I mean, I'm still pretty new to this, like very new to this.
Same for me.
So the next dimensions I want to get are outside, inside of this sketch, a lower layout, right? I should probably just pin this so that I'm not having to do that all the time. And we're going to call this one leg height. Let's add that. And then they had another one here that we're going to grab that is the overlap. Right? And they just want to call this one minimum overlap. Let's add that. Right? And then there's some features too that they want, like, so if this goes over a certain like width, we need these features. If it's under it, like we could just suppress them, right? Similar to what you're trying to do with that if-then statement, right? Only this one time it will work. Just kidding.
Very nice.
So features. Got to move you out of the way for a second here. There we go. There's this inner diagonal. So I just select it from the feature tree over here and click add. And now I have my feature that I can control, right? Next thing that they want us to grab here is some custom properties. So we're going to go back to our assembly. All right, there's a custom properties section here, and I can pick and choose the different custom properties that I want to drive, because I might want to change those for like a drawing or something like that, right?
Mm-hmm. Yeah, that makes a lot of sense for, you know, like we were saying before, this is going to be your next customer specific thing. You're going to change some of that information that goes on your drawing, that kind of stuff.
Yeah, you could have customer name, like I could add in additional properties here too if they're not in the model, but
yeah, that's really cool.
The next thing we need to do is include any drawings that are already created. So under drawings and configurations down here, I should be able to just browse and I think I did the right thing. Open drawings and configurations. Okay, they just wanted one drawing here. So browse, and it is the gantry drawing. All right, And then we can go back to our captured models here. And the next thing they want us to do is look at the universal beam. Potentially want us to be able to switch between different configurations. So under drawings and configurations here, we can switch this and say, yes, allow me to use a rule to switch between configurations.
Nice.
All right, and then the next thing that we need to do is just actually get into building our form. So there's little buttons up at the top here, right? The kind of database selector, our capture, and then we can create our form. So I'm going to create my form next here. And so you just start by clicking on add, and then we can choose the type of thing that we're trying to add to that. And in this case, it's going to be text box, and we're just going to call this safe working load. Oh man, there's no spell check in this, but it's complimentary, so it's okay. So this is going to be text box. We have it set to required, and we should be able to hit create. And then we could add another one here for, oops, you know what? I need to go back. This one, I'll use that in a second, but this one should have been project number. I was getting ahead of myself.
I like that required input part to make sure that whoever's going to fill out the form does it correctly.
Yeah, especially for the project number, because that's going to be part of the file name. So that could be a problem if they don't put one in there. Like if you had something that was like a default value and you didn't want to change it, then sure, make it optional. But
sure,
for something like a project name, like you got to have it every time.
Oh yeah.
Safe working load. So for this one, instead of just doing a text box, maybe I want to do like a drop list. So they have to pick between options that I have here for them. So 500 kilograms and then 1,000 kilograms and 1,500. And so those will be their options. And then we'll do another one here for our working height. So we'll call this opening height. If I make typos and stuff, just I'm trying to go through this, trying to talk, type, and read at the same time doesn't really work for my brain.
I won't judge.
Reading
man.
Reading's hard enough for my brain. So they were doing a spin box for this one. So this one, like, you know, you can specify the increment value. So every time I want to move it, I'm going to move it by 50. And we're going to go, the smallest you can put in there is 1,500, and then the largest is going to be 2,500, something like that.
That's pretty easy to set those up.
Oh, it's so easy. Yeah. Well, and especially compared to like if I was trying to do this with a macro, right? This is how I would typically have done this in the past. Is creating a form and driving dimensions and stuff by name, and navigating the model and stuff using the API, which is doable. It's fun in a really nerdy way, but it's not efficient. Not at all efficient.
That's getting to a level right there that's beyond me. Like I haven't even explored those options. So
we'll get there.
A user interface for me is perfect. I mean,
yeah, I mean, especially if you have somebody that's doing like a multi role, right? Like often like you have sales engineers and stuff, right? People who are doing like I have multiple hats. So you can't spend all of your time, you know, just driving SolidWorks.
Yeah, makes sense.
Maybe. I don't know necessarily what I'm saying. Sometimes I just ramble while I'm clicking buttons and trying to read. So you got our opening width there too. We could test this, but it's just gonna pop up a form. I should probably test it. Looks good. go back to the design mode. And if we need to delete or edit those things, we can use our controls there. But
Nice.
With all of these things, with the things that we've captured, the form that we've created, now we need to implement this. So what we're going to do to implement it is go to our rules. And we can selectively choose the rules that we're going to use here, or we could just click on the little checkbox at the bottom and edit all the rules at once. All right. And then we can see the different items that we need to drive. Right. And some of them are going to be like the files themselves, giving them like file names. Right, like our parts and our assembly. So I think we're going to do our part here first. So if I double click on it, I can control the file name of that. And I'm going to do the project number as file name. I guess it's just the project number there. And I can just hit OK. Right. I should probably just do the property for the project number while I'm here also, because that's just going to be project number. I can do the custom property for the working load also while I'm here, safe working load. All right, and then we'll probably do something a little bit more complex for these other ones. So the universal beam is the next one that they want me to drive. And we're gonna do, I believe, the project number first. Project number, all right, and then we're gonna use some functions here. So I'm gonna combine some stuff together. So I've got the project number, and then I want to put a space in there. So I'm going to do a string with just a space in there. So you got to make sure that you have the quotes and the space in between.
Okay.
Right. And then I want to put some text after that. So I'm going to need another and. Right. And then they say, oh, I need the opening width actually. Width. Okay, so project number, space, opening width, and they wanted to say wide dash, and then after that we're going to do another and, right? So we have the width, and then they wanted the safe working load for the next thing. So I need to drop in that safe working load and then actually say after it. And hopefully that makes sense. So this is going to be a value that I'm getting from the user, right? And then I'm going to put a space, and then I'm going to get another value from the user that's the actual width, project number, width, and then I'm going to say that's how wide it is. Then I'm going to get another value. I'm going to say this is the safe working load. That'll be the file name.
Got it. Okay.
Hopefully that makes sense.
Yeah. So it's just it's pulling those variable values that the user's inputting, and it'll make a string of text out of it.
Yep.
Nice.
And then we got the leg. We've got to do the same thing here for the leg too. So the leg, we're going to do again project number. So like all of the documents that are part of this project, you're going to start with project number. So that makes it easy, kind of like serialize things sort of here. And then and the opening height, right? And then we're going to put in some text to say that this is the height or high that we're talking about. Yep. And then next thing they want us to do is look at the configurations rule. So let's go ahead and double click on that. They just want me to, let's see, go to my inputs, and then for the configuration name, I believe, we're just going to say that it's the safe working load.
I see.
Okay.
So all of that stuff was really just naming conventions. That
Just naming. Yeah, we haven't actually driven anything yet. We could run it and it would, well, I think it wouldn't like it because we're not writing anything to the values of these dimensions. But if it did run, all it would do is change the names of the files.
Yeah. Well, even that right there is kind of a powerful thing.
Yeah, if that's all I needed to do, right, I could have just not captured a lot of these things and run it and it would work. I already did the custom properties, so we can kind of skip over that one. The next one here that they want us to get is the leg height. And for the leg height, I believe they just want us to reference opening height. Whatever the user puts there is what we're going to put in that dimension.
Mm-hmm.
And then get the opening width. Did I miss that? Beam length. Did I just write to the wrong one? Maybe I didn't capture opening width. Well, it doesn't look like we're driving opening width. All right. I'll go ahead and skip over to the beam length here. So beam length. All right, to my input that's right. I know what I was thinking. It's late and I'm doing lots of things at once, I guess. The opening width is like one of the values from my list. I'm an idiot. It's all good. So I grabbed that dimension beam length and I'm writing opening width. And that's okay. That's all that they wanted for that one. For the beam height though, they wanted to do something a little bit more fancy. So we're going to do an if statement. So got a little bit more fun stuff we can do in here. So here's that if. All right, so we're going to say if the safe working load is 500 kilograms, then the dimension value is going to be 200. Otherwise, it's going to be 250.
See, I figured that was going to come in at some point.
Yep.
The safe working load makes sense, how you were looking at like 3 well-defined values. I like that you can make it dependent like that.
Yeah, 200 and 250. Yeah, it makes it really nice. And I think you can even like nest these things together too, if you needed to.
Well, and it makes it a lot more realistic too. I mean, you can base something, make those dimensions anything you want, but in reality for manufacturing, I mean, there's not just an infinite number of choices you can make.
No.
For most things, right?
No. Yeah. Yeah, and there's a lot of like manufacturing processes and stuff that you could potentially integrate if you're doing something like driving it like this. So
yeah, and especially if you're going to take this to like a customer facing type thing, they don't want a million options. They want you to make it simple for them. So
yeah,
give them 3 choices.
Yep.
I like it.
Okay, so then we're going to do the minimum gap here. So that they wanted us to do for this one, just a really simple equation where we're going to take the height, we're going to divide that by 10, and then we're going to add 100 to that. So you can do some simple math and stuff in there too. But next thing that we need to do here is actually control that that feature, right? Turn on and off that feature dependent on one of our other dimensions. So we'll do another if statement, logic if, and we'll say that the opening width, if it's greater than 3,000, then we're gonna unsuppress the gussets. Otherwise, we're gonna suppress I guess it's, yeah, something like that. And we're done.
Very nice. Cleared out the whole shopping list.
Yeah. And if you wanted to see those, if you want to go back and edit it, you just uncheck the show missing rules, right? It's just a really nice, like you said, like, kind of like a shopping list, right? As you go through it, just check it off. Make sure that you hit all those things that you meant to do.
Yeah, makes a lot of sense.
But once it's done here, I should be able to, let's go ahead and run it. So we'll go to the run here. 1, 2, 3, 4 will be my project number. My working load, 1,000 kilograms. Oh, make it something special. And let's see, we'll go with 2,500. And create. And I only need to do that setup once, right? Like, that's what I think the amazing thing about it is, like, once you're done with that setup, you're all set, you know?
Yeah. And this is a really simple example too. Like, we went through a bunch of steps that capture a ton of information, but you can get really, really detailed with all those inputs and using your variables and math functions.
Yeah. And it looks like I messed up the configuration thing because it didn't have a configuration named 1,000 kilograms, but you can switch configurations. just me
sense.
Being not good at this. But I've literally done it twice now. So
only twice?
Yeah.
Yeah, we got to cut you some slack then. I think it looks good.
I think so. And like, again, the important thing with it too is that there's drawings and stuff that went with this. Here's my drawing.
Yeah.
Right. And this could be a multi-sheet drawing. Like, it could be as complicated or as simple as you need it to be. So pretty powerful stuff.
Nice. Probably one of the biggest things that I like here, well, a couple of things. It's the full package, all automated, like you said. You get your parts, your assemblies, your drawings that go along with it. The other thing too that really kind of ties all this together is the first approach that we took with doing all those equations. I've got a lot of logic that is tying all that information together with each other in the model, right? So it has to go through and rebuild everything. Whereas with DriveWorks, we're basically just taking that seed model, if you will. We're changing the variables, but they really don't have to link to anything. I just push out some new values and create those new files. That's really powerful because now I have something that's a lot more lightweight to manage than what I would with a ton of equations, right?
Yeah, absolutely. Yep. And it's anything that, like, you're not changing, you're still referencing back to like shared libraries potentially too, if you wanted. Anything that's customer specific, you're potentially putting in the customer specific folder. Like, kind of, there's some best practices and stuff that are built in here too that I never really thought about.
Yeah. Yeah, that's a really good point to bring up, the common parts library. Like, when I DriveWorks with people, that's a topic that comes up almost every time. How do you manage that? Well, you're only choosing what you want to make the next customer specific model from.
Yeah, only things that change actually get new copies, right? So
I like it.
Yeah. What was our support question for the day? Remember?
Let me take a look here.
I got it. So, Brandon, how do I update the default units for SolidWorks?
Update my default units.
Your template.
Yeah, well, that makes me think of, I would want to create a template. Is that where you're going with that?
Yeah, I mean, you could create a template. If I just want to update the one that's there, like, what do you do? What's the simplest way to do that?
Well, I would open my template, change the units, and save it.
Yeah, that's exactly what I do, right? You just create a new part, change the units, and then save it as a template over the top of the existing one, right? Or if you wanted one that is like feet and inches, or however you want to do it, like, just change the units and give it a different name, and now you have another template. That's your feet and inches template. So
perfect.
Super easy, super easy. But yeah, I think we made another long one today, but not as bad as last time. So
yeah,
there was so many things last time that we didn't talk about too. So
that's always going to be the case. I mean, we always got something to talk about. We're always going to miss a little something here and there. So
yeah,
hopefully everybody enjoyed it. I know I did. There's a lot of different ways to come at this problem of design automation. So hopefully that showed you guys a few different ways that can help you out on your journey or what you need to automate. But yeah, had a lot of fun.
Yeah, and I think next time we're going to talk about optimization and design studies.
Perfect.
Right? So
I like it.
That'll be all you, man. I don't know anything about that. I know what I teach people in like the essentials class about optimization. That's about it.
Very cool. Yeah, that's definitely will be a fun topic to discuss. There's a lot of different directions you can with that too. So I like it.
Cool.
We should have some fun next time. So we will call it a Friday, and thanks so much, Garrett, for taking us through the DriveWorks example. It was really fun to see it implemented.
Yeah. All right, guys. Thanks for hanging out.
Well, we'll see you on the next one.
Talk to you later.